Hello everyone, welcome back to my channel. This is question number 3, exercise 1.3, grade 9. Express the following in the form of P by Q. Q not equal to 0, where P and Q are integers. The first question is 0.6 bar. 0.6 bar ni manam P by Q formula express cheyali. To that 0.6 bar, let 0.6 bar as x equal to 0.666 up to so on. This is equation 1. Then so we have to multiply the equation 1 by 10 on both sides. So like this, 10 times x equal to 10 times 0.666 and so on. So if you multiply this, 10 times x is 10x and the 0.66 bar multiplied by 10, the decimal point shifts one place towards the right. That means 0.66 bar becomes 6.666 and so on. Let it be equation 2. Now subtract the equation 1 from equation 2. So 10x equal to 6.66 and so on minus x equal to 0.666 and so on. 6 and 6, all 6's will be cancelled and write the decimal place and 6 cancel 0, 0. It becomes all the 6's becomes 0 and put a decimal point below the decimal point and 6 minus 0 is 6 and 10x minus x is 9x. Now this is in the form of algebraic equation 9x equal to 6. So x equal to transpose 9 to RHS 6 by 9. Simplify by 3. Both numerator and denominator. 3 2s are 3's. Therefore, x equal to 2 by 3. So, P by Q form of 0.6 bar is 2 by 3. The second one, 0.47. How do we represent 0.47 in P by Q form? For that, let x equal to 0.444 and so on. Here, bar represents repetition of the digit. Only 7 is repeating. So, 4 write at once and 7 is repeating. So, only one digit is repeating in the decimal expansion. So, we have to multiply the decimal number, this equation 1 by 10 on both sides. So 10 times x is 10x and 10 times 0.477 bar is 7 is 4.777. This is equation 2. Now subtract equation 1 from equation 2. So equation 2 is 10x equal to 4.77 and so on. And first equation is x equal to 0.77. First equation is x equal to 0.477 and so on. So all 7's will be cancelled out. Here 4 minus 7 is 7 minus 4 is 3 and place the decimal point below decimal point and 4 minus 0 is 4. 10 times x minus x is 9x equal to 4.3. So transpose the 9 to RHS. So it becomes x equal to 4.3 by 9. See, x equal to 4.3 by 9. We have a decimal point. To eliminate the decimal point at numerator, we have to multiply both numerator and denominator by 10. 4.3 times 10 is 43 and 9 times 10 is 90. So x is 43 by 90. What is x? X is a 0.477. So P by Q form of 0.47 bar is 43 by 90. See, this is method to short form of the P by Q form of the decimal expansion of the repeating decimal expansion. So 47. How many digits are there in the decimal expansion? 0.47. So repeating decimal should write only once. 047. Write all the digits in the decimal number. Repeating decimal at once and subtract the non-repeating decimals by the whole 47. So 47 minus 4 is 43. So how many digits are repeating? Only one digit. So 43 by 9. If one digit repeat by 19 వేసుకోవాలి. After that, after the decimal point, one digit is there with non-repetition. So non-repeating decimal non-repeating decimal we have to write 1 0 after the 9. So this is the shortcut method of the P by Q form of 0.47 bar. Next, third question, 0.001 bar. P by Q form of 0.001 bar is let x equal to 0.001001001 and so on. So here bar represents the repetition of the block of digits. What 001 is repeating. So let it be equation 1. So 3 digits are repeating. So we have to multiply the equation 1 by 1000. So 1000 times x equal to 1000 times of 0.001001 and so on. 1000 times x is 1000 x equal to, so if we multiply this decimal number by 1000, the decimal point shift 3 places after the 3 digits in the 0.001001. So that means 1.00101001001 and so on. Now this is the equation 2. So subtract equation 1 from equation 2. So equation 1 is this, equation 2 is this. So equation 2 minus equation 1. Subtraction is all 1 0 0 1 1 0 0 will be cancelled and 1 minus 0 is 1. The 1000x minus 1x is 999x. So 999x equal to 1. Divide both sides by 999. So 999 will be cancelled. Then x equal to 1 by 999. So as we see in the second question, this is the shortcut method. Express 0.5 999 and so on in the form of P by Q. Are you surprised by your answer? With your teacher and classmates, discuss why the answer makes sense. For the solution, 0.999 and so on is equal to 0.9 bar. Let x equal to 0.999 and so on is the equation 1. And only one digit is repeating, which means periodicity is 1. So multiply the equation 1 by 10 on both sides of the equation 1. So if 10 times x is 10x and 10 times 0.999 is 9.999 and so on. Let it be equation 2. Now subtract equation 1 from equation 2. Subtract equation 1 from equation 2. Then all the 999 will be cancelled out. And 9 minus 0 is 9. And 10x minus x is 9x. Therefore, 9x equal to 9. Then divide by 9 on both sides the equation. 9 gets cancelled. Then 9 by 9 is 1. Therefore, x equal to 1. But finally, we get x equal to 1. That means 0.999 and so on is very closer to 1. The difference between 0.999 and 1 is the difference of 1 and 1. Difference between 1 and 0.999 is negligible. What can the maximum number of digits be in the repeating block of the digits in the decimal expansion of 1 by 17? Perform the division to check your answer. So, by dividing 1 by 17, we can find the repeating block of digits in the decimal expansion. So, let's perform the division. So, this is the division I performed. So, 17 divided by 1. 17 divided by 1 is not possible. Then write a decimal point, put a point at quotient and then write 0. Then write 0. And again 10 is also not divisible by 17. Then write again take 0 and we can take another 0. So, it becomes 100. Now 17 5s are 85. 85 is the closest multiple to 100. So 100 minus 85 is 15. So 15 is not possible to divide by 17. So since we have a decimal point, then we can write 0. Then it becomes 150. 150. What is the closest multiple of 17 to 150? It is 17. 8s are 136. 17 8s are 136. 136 is the closest multiple to 150. 150 minus 136 is 14. Again, write 0. Since we have a decimal point at quotient, each time we can write 0. So 140. Closest multiple in 17 table is, it is 17. 8s are 136. 140 minus 136 is 4. Then write 0. And now 40. In the 17 table, 34 is the closest multiple to 40. 40 minus 34 is 6. Remainder 6. Because of decimal point, we can write again 0. Now it is 17. The closest multiple in 17 table is 51. The closest multiple of 17 to 60 is 51. 60 minus 51 is 9. Then write 0. Then 90 minus 85, or the closest multiple is 85. 90 minus 85 is 5. 5. Then write 0. It becomes 50. In the 17 table, the closest multiple is 34. 17 3s are 51. So it is greater than 50. So take 17 2s. 17 2s are 34. 50 minus 34 is 16. 16 also less than 17. So we have to write 0. Then it becomes 160. 7. What is the closest multiple to 160? 17. 9s are 153. 17 9s are 153 is the closest multiple to 160. 160 minus 153 is 7. Then write 0. Write 0. 70. Now it becomes 70. The closest multiple of 17 is 17 4s are 68. 17 4s are 68 is the closest multiple to 70. Then 70 minus 68 is 2. Remainder is 2. Write 0. Then it is at 720. The closest multiple to 20 is 17 ones. 17 ones are 17. Then 30 minus 17 is 13. 13. So 13 is smaller than 17. Then write 0. 130. What is the closest multiple to? Closest multiple of 17 to 130, it is 17 7s are 119. 17 7s are 119. 130 minus 119 is 11. So remainder is 11. There is no space. That's what I have written up. So 11 is a remainder. 11 is lesser than 17. Then write 0. Since we have a decimal point at quotient, then write 0. It becomes 110. In the 17 table, closest multiple. 17 6 are 1 or 2. 110 minus 1 or 2 is 8. So write 0 again. It is 80. The closest multiple is 17 4s are 68. 80 minus 68 is 12. 12 is also less than 17. Then write 0. The closest multiple to 120 is 17 7s are 119. Now 120 minus 119 is remainder 1. We get same digit where we started. We started at 1. So now the remainder is the same. So we are going to get same reminders again if we continue the division. So these are the repeating block of digits in the decimal expansion of 17, 1 by 17, which is 0.0588235294117647. This is the repeating block of digits in the decimal expansion of 1 by 17. Sixth question. Look at the several examples of rational numbers in the form of p by q, q not equal to 0, where p and q are integers with no common factors other than 1 and having terminating decimal expansion. Can you guess what property q must satisfy?
If q is in the form of either 2 power n into 5 power m or only 2 power n or 5 power m, then q must satisfy this property. Then only the decimal expansion of the rational number is terminating. Look here, if the denominators of the q are any rational number, which means q must be either 2 or 4 or 8 or 5 or 10 and so on. They must be in the form of 2 powers or 5 powers or 2 times 2 into 5 powers. So this condition q must be satisfied to be the rational number, the decimal expansion of rational number, then only it is a terminating. Look here, 1 by 2 equal to 0.5. The examples 1 by 2, 4 by 5, 7 by 8 and 6 by 10. All these are in the p by q form, and the denominators are 2, 5, 8 and 10. So 1 by 2 is 0.5, 4 by 5 is 0.8 and 7 by 8 is 0.785. So all these three rational numbers are terminating decimals and its denominators are in the form of either 2 power n or 5 power m or 2 power n into 5 power m.
Write three numbers whose decimal expansion are non-terminating and non-recurring. Which numbers of decimal expansion is non-terminating, non-recurring? We already know that. Irrational numbers, decimal expansion of irrational numbers is non-terminating and non-recurring. All rational numbers are either terminating, it has either terminating decimal expansion or recurring decimal expansion. Only the irrational numbers decimal expansion is non-terminating, non-recurring. Such the numbers are the irrational numbers are root 3, root 5, root 6 and so on. There are infinite irrational numbers also. So root 3 is equal to 1.732050807568 and so on. Any of the block of digits is not repeating in the decimal expansion. So it is a non-terminating and a non-recurring. Root 5, 2.23606797749997 and so on. So this is the root 5 decimal expansion. There is no block of digits is repeating, and root 6 also 2.449489742783 and so on. So in none of the repeating block of digits are in the decimal expansion. So these three are the examples of non-terminating, non-recurring decimal numbers. Find the three different irrational numbers between the rational numbers 5 by 7 and 9 by 11. To find the irrational numbers between 5 by 7 and 9 by 11, first we have to find the decimal expansion of 5 by 7 and 9 by 11. The 5 by 7 decimal expansion is 0.714285 bar, because this is the repeating block of the digits of a 5 by 7. See, I performed a division, then I got the answer. Next, 9 by 11. The repeating block of the digits of 9 by 11 is 0.81 bar. 81 is repeating. So, we can write infinite irrational numbers between these two rational numbers. For example, here we have three irrational numbers between 5 by 7 and 9 by 11, 0.724285 and so on. Any of the different digits we can write after this. Now 0.7345017, none of the digits of block of digits is repeating in this number also. Third one 0.75050055005. Here also any of the pattern of the digits is not repeating. So these three are the irrational numbers which lie between 5 by 7 and 9 by 11. And classify the following numbers as rational or irrational. Look at the first number, root 23. 23 is not a perfect square number. Square root of any perfect square number is rational. Otherwise, it is irrational. Root 23 is irrational. Next, square root of 225. 225 is a perfect square number. It is a perfect square number, which means this can be written as 15 square. Look here. Square root of 225 can be written as square root of 15 square. So square and root gets cancelled, then the rational number answer is 15. Square root of 225 equal to 15. 15 is a rational number. Third one, 0.3796. This is the decimal number, and also it is a terminating decimal. There is no other digits and continuous expression in this. So this is a terminating decimal. Every terminating decimal is also a rational number. Thank you. For more videos, follow my channel and give your suggestions to improve